Hello everyone, this is Tarun from Testing Gyan. Today we are going to discuss a very important problem in the series of array data structure programs, which is two-sum problem. So let us first understand the problem. So problem is very straightforward. We are given one array. As you can see, we are having this array 1, 2, 3, 4, and we are given one target. So our output should be the indexes of the array which contributes to this target. That is, if we add the elements at these indexes, then it should return the target. So here we can clearly see if we add 2 and 4, it will return 6. So our output is 1, 3. So there are few assumptions with this problem. So first assumption is like there only one solution which exists, that is there is no other possible solution which will give us the target as 6. Okay. Second, adding the same element is not possible, that is if we do 3 plus 3, that is not allowed. The third one is result indices can be in any order, that is our output can be 1 3 or 3 1, that doesn't matter. Now let us see the approaches which we can use in order to handle this problem. The first approach which we are going to discuss is brute force approach. So brute force approach is pretty straightforward. In this approach, we pick one array element at a time and then we compare it with the elements which are right to it. Okay, that is, we keep on adding the elements which are right to it, and if it matches the target, then we will return the indexes. That is, if our array is 1 2 3 4, then first we will check, we will start with the element 1, that is element which is present at the 0 index. So it is 1 in this case. We will check 2 plus 1 is not equal to target, 3 plus 1 is not equal to target, 4 plus 1 is not equal to target. So we can see if we add any number in 1, then it will not result into 6. So we will move forward to the next element. So 1 is cancelled. Let's move forward to the second element. In second element, we will check again 3 plus 2 is not equal to the target, which is 6. 4 plus 2, however, it is equal to the target. So what we will do, we will simply return the indexes, that is index of 2 and index of the 4, which is 1 and 3. So this results in the output. So if we would have not found this result using 2 as well, then we would have moved forward with 3 and 4. So we will go with all the elements until we are finding the target, and if we are not finding the target, in that case we will be returning -1, or we will return the empty array which will have the indexes. Okay, we will be using an array to store the indexes, so in that case we will be returning the empty array. So the time complexity for this solution will be, we will be using one loop to pick one array element at a time, and second loop to compare it with the elements which are coming next to it. Okay, so that we are using two loops, so time complexity will be big of n square in this case. Space complexity will be big of 1 because we are not using any additional space. Okay, now let's see the efficient approach to solve this problem. So the efficient approach will be by using a hash map. Okay, so what we will do, like for our given array, we will also create one hash map. Let's consider this is our hash map. Okay, so we know our target is 6. Okay, so we will pick one array element at a time. Okay, and we will check if target -1, that is target minus that element which we have picked. Let's say if we have picked 6. Okay, then we'll see if 6 minus 1, which is equal to 5. So in this case, we will check, does this element exist in the hash map? If not, then whatever element we have picked, that is 1 in this case, we will store that element. That is, that element will go as key and its index will go as value. Okay, in the hash map. Okay, this is our map. Now we know the first element is 1. Okay, so 6 minus 1 is equal to 5. We will check, do 5 exist in the hash map? No. So what we will do, we will store 1 comma 0, that is element 1 and its index in the hash map. This is our first element. Now we will move forward with the second element. So our target is 6, element is 2, so 6 minus 2 equal to 4. We will see, do 4 exist? No, 4 also do not exist. So we will store 2 comma 1 in the hash map. Then we will move on to the next element, which is 3. We will check 6 minus 3 is equal to 3. We will check, do 3 exist in the hash map? No. So we will do 3 comma 2. Okay, then our next element is 4, which is the last element in the array. We will check 6 minus 4, which is equal to 2. Do 2 exist in the hash map? Yes, 2 exist in the hash map. So what we will do, we will return the index of element 4 from array and index of element 2 from the hash map. So this will result in our output as 3 comma 1, which is our expected output, and as we know, it can be of any order. Okay, so this is our efficient approach. So the time complexity for this solution will be big O of n, as we are using only one loop. Okay, although we are doing some insert and search operations from the hash map which are equivalent to big O of n only. Then the space complexity will also be big O of n, as we are using an additional space which is hash map to store the key value pair. Okay, now let us see the implementation of both of these approaches. Now coming to implementations, the first implementation is for the brute force approach. As you can see, the time complexity for brute force approach is big of n square and space complexity is big of 1, right? After that, we are having two inputs. One is the array and then the target. The first thing which we did is to find out the length of the array, and then we created a resultant array which will store the indexes of the pair. Then we started our first loop, which will pick one array element at a time. Then we started our second loop, which will sum up the next array elements with the picked array element, right? And after that, we are summing it up and we are comparing it to the target. If it is equal to target, then we are storing those two indexes in the resultant array. And at the end, we are returning our resultant array. So this will give us a pair which will be having sum equal to the target. Now let's move on to the efficient approach. So as you can see, this is our efficient approach. In this, our time complexity is big of n and our space complexity is also big of n, as we are using a hash map here, right? You can see we are having two inputs again, like one is the input array, second is the target. You can see the first thing which we did is to find out the length of the array. Then we have created our hash map to perform our operations, right? And then this is our resultant array which will store the indexes of the uh, pair. Then we started our loop which will go till the last array element. Now we are checking like if target minus array at I, right? If it exists in hash map, then it means result will be the current array index and the index which we will get from the map. And if it is not, then in that case, we will be putting the array element and the index into the map, right? And at the end, we will be returning a result. So what will happen in this case? Let's say in first iteration, we are not finding target minus array I in the map, then it will go and put it into the map, right? In the second one, again, we are not finding target minus array I, it will put it into the map, right? But let's say in our third iteration, we found that target minus array I do exist in the map. So what it will return? It will return the current index and the index which is stored in the map, and it will store both of those values in the resultant array, and it will return us the resultant array. So this is our efficient approach. Now we have one more approach, right, which is like also an efficient approach, but it is more efficient if array is sorted. If array is not sorted, then this will be our time complexity, which is big of n log n plus big of n. N log n is for the sorting of array and big of n is for the operations. Then if array is sorted, then our time complexity will be big of 1 n, sorry, and space complexity will be big of 1, right? Now in this approach, basically we will be having two pointers, one pointer at the first array element index and the next pointer on the last array element, right? Then we will be sorting the array. If array is already sorted, then in that case we don't need to do that. But yeah, if array is not sorted, then we will first sort the array. Then after that, what we will do, we will check until I is less than j, that is the start index is less than the last index of the array, and till that we will start one loop and we will see if array at I plus array at j is equal to target. If it is equal to target, then it is our result, right? We will store it in the resultant array and we will return our result. But in this case, if we observe, if our sum is less than target, right, then it means we have to increment the array element from the left side. That is our I will increment because array is sorted, right? If it is, if the sum is greater than target, then in that case we have to decrement the pointer from the right side, right? So what I meant by that, let's consider this example 1 2 5 4 3. First it did the sorting and sorting array. After sorting the array, we got the output as 1 2 3 4 5. Now let's assume our target is 8. So what will happen in this case? We will have I at this array element and j at this array element. index, right? So our loop will start. Okay, so 1 plus 5 equals to 6, right? So 6 which is less than the target. 6 is basically less than the target, right? So what will happen? We will increment the I and it will come to 2, whereas our j remains here. Okay, so again it will do 5 plus 2, which is equal to 7. Again 7 is less than the target, then it will increment I again and it will reach here. Okay, j remains at the 5 only. So 5 plus 3 equals to 8, which is our target. It will go into this if clause and it will return the resultant array in this case, right? Now let's assume our target is something which is lesser, right? In that case, let's assume our target is 5, right? So what will happen? So when we did 1 plus 5 equal to 1 plus 5, it gave us the 6, which 6 is basically greater than 5. So in that case, what will happen? We will move our j pointer to the left side. That is, we will decrement j, I remains same. Then 4 plus 1 equals to 5. It will give us the resultant array. So these are basically three approaches which we can basically follow in order to find the two sum, that is the pair, which will give us the target sum. Now let us see the working of all of these three approaches. As you can see, this is our input array 1, 2, 5, 4, 3. The first approach is to sum, second is to sum efficient, third one is to sum two pointer. So it will be printing out the output in all of these three approaches. Now if I run this program, you will see they all gave us the same output, which is 2 4 4 2 2 4, right? Order can be different in the second approach, which is our efficient approach, so it's fine, but our output is same only. So I hope you guys got the understanding of all of these three approaches. In case of any questions or queries, please let us know over the video comments. Thank you.